Hey everyone, welcome for my viscosity experiment. Today we're going to be doing two things. First, we're going to test the rate of flow of different syrups to see how fast they'll go down the board. We're going to be racing cane syrup, Rogers cane syrup, delicious on Rice Krispies. You should try it sometime. We've got some standard pancake syrup, some honey, and some fancy molasses. So for this part of the experiment, we've got our inclined plane. I've measured this already. It's at a 45-degree angle. And our track is exactly 30 centimeters in length. So we're going to be rolling these syrups down the plane when the time comes. And if you'll come over here, for part 2 of the experiment, we're going to be testing the viscosity of 2 different oils. So this one here is olive oil. You can see that the color, it's a little bit foggy. So this has been in the freezer, or rather it's been outside. So it's nice and cool for our first trial. This oil here is canola oil. So what we're going to be doing is pouring both of these into the graduated cylinders, and we're going to be dropping dice in, and we're going to see how quickly the dice drop. So that is the procedure for the experiment. Let's get started. So with every good science experiment, we have to keep track of what we're doing. Here is our scoreboard. So I'm going to be taking the temperature of our syrups and I'm going to be recording them right here. And then as those syrups pass over the finish line, we're going to write the race time over here. So make sure you're checking out this board throughout the experiment and logging this into your data table in the lab manual. You will note up here we have one piece of information already. The length of our track is 30 centimeters. You're going to want to make sure that you put that in your chart to start. Okay, so for the first part of our procedure, we're going to put our syrups into beakers so that we can take their temperature and so they're easy to extract with syringes. So let's get started. First, I've got the Rogers golden syrup. So I'm going to put about, maybe about 40 milliliters. We're only going to use 20, but just in case you need some leftover. Maybe some of you can make some predictions about how the cane syrup is going to behave in the race. It's pretty sticky. Next, we have the pancake syrup. Okay, so what can you think about the viscosity of this fluid? Does it come out easier or does it come out a little bit slower than the cane syrup? Next, we've got our honey, made in Canada. Isn't that nice? Okay. Honey, I wonder how honey's going to behave. Oh, I've got to put a lot of force in that bottle to push it out. Getting my arm workout for this experiment. Oh my goodness, you can even see how slow it is to take the shape of the container. I'm gonna add a little more honey just so we're not short. I hope maybe my facial expression can be a bit of an indicator of how the honey's gonna do in comparison to the others. Okay, and last we've got our fancy molasses, 100% pure. Okay, let's see how the molasses go. Oh boy. Any day now, molasses, any day. Okay, that's enough. Kind of reminds me of the tar substance we talked about earlier. That's the thickest fluid in the world. So this molasses are being like right now. Okay, that's going to be difficult to open later. Okay, so let's take the temperatures now. So here I have my trusty meat thermometer. I use it all the time. And I'm just going to submerge it into the fluid and we're going to see about what temperature it is and I'm going to record that. So first I'll start with the cane syrup. So it's slowly dropping. It's at about 21 degrees Celsius. So we'll give it another few seconds, but I think it's gonna kind of bottom out at 21. So while that's settling, I'm gonna go over here and go and record on our chart the temperature of the cane syrup. So it read at 21 degrees Celsius. Yes, I remember to change it to Celsius. Most meat thermometers, you read in Fahrenheit. Okay, so I'm just gonna clean that off. Why might it be important that I give the thermometer a good clean? When you're doing science experiments, you wanna make sure that you're pretty clean, you don't mix things up. So next I'm going to temp the pancake syrup. And ideally these should all be about the same temperature, but it's always good just to make sure because we're going to be looking at temperature in this experiment. Okay, so the pancake syrup's at about 23 degrees. 2 degrees warmer, it's a bit of a difference, but we'll see if that makes a big difference later on. Okay, so I've recorded pancake syrup is 23, and I'll make sure you have a good image of this shortly. Okay, we'll clean off our beaker here. Let's see what temperature the honey is. Okay, and the honey's coming up at 21 degrees as well. Okay. And last but not least, we have the molasses. Okay. Okay, now the molasses is temping at 20 degrees. So there you have it. We've recorded our temperatures of each of the syrup. Cane sugar being 21 degrees, pancake syrup being 23 degrees, honey is temping at 21 degrees Celsius, and molasses coming in at 20. So make sure you get this data written down in your lab report. Okay, so we've had our first blooper. When I tried to pull the cane syrup with a syringe, it was so thick. You can watch here that it won't even pick it up. It only picks up. It basically creates a vacuum. So we're not gonna be using the syringes today. We're just gonna pour them onto the board and see how that goes. Okay, it's race time. So we're gonna do 2 at a time just so we can watch them very closely. We're gonna race the pancake syrup as well as the Rogers cane syrup. So just to keep things straight, I'll just make sure I have cane syrup on this side here. And I'm gonna pour both beakers when we're ready to start recording. We're gonna see which one crosses the finish line first. 3, 2, 1, go. Pancake syrup's pulling up the finish line. Look at it go. Cane syrup is trailing behind. Absolutely trailing. Cane syrup is past the halfway mark after 1 minute and 10 seconds. Come on, cane sugar, that could. And it's crossed the finish line at 2 minutes and 22 seconds. Wow, what a difference in rate. Okay, so here comes trial number 2. So we're going to be racing honey and molasses at room temperature. It's quite cool for room temperature. It is about 20 degrees, but we are going to race these guys. So we're ready to record the timer. Gonna get started. Okay, who do you think is gonna win? Who's gonna cross the finish line first? I don't know, they're both pretty sticky fluids. Let's see. Go! At the halfway point. And molasses is drying up at the finish line at 2 minutes and 14 seconds. And honey crosses at 4 minutes and 47 seconds. So if you haven't had a chance to get these into your chart yet, here are our final results from part 1, rate of flow at room temperature. So what we're gonna do to these same fluids, we're gonna heat them up. And I wonder if they're gonna go faster or slower with a warmer temperature. Okay, so now we're gonna finish up part 1. What I've done is I've microwaved all of these syrups for 20 seconds. So it should be a little bit warmer than last time. So just like last time, I'm gonna take the temperature of each, and then we're gonna see how fast they travel down the ramp. See already, it's a lot less viscous, a lot runnier. So, there you have it. Cane syrup is temping at 60 degrees Celsius. The pancake syrup is temping at 52 degrees Celsius. Our honey at 65 and molasses at 60. These were all in the microwave at the same time, so it's interesting to see such a variation in temperatures. But the meat thermometer doesn't lie. Okay, so now we are finishing up part 1. We have our warmed fluids. We put these in the microwave for 20 seconds. So just like last time, we're gonna race the cane syrup and the pancake syrup. I'm not gonna pour the whole container, just a little bit to avoid mess. So on 3, 1, 2, 3. Whoa, a lot quicker than last time. All right, so pancake syrup and cane syrup ran pretty fast. Let's see how honey and molasses do. 3, 2, go! Who's it gonna be? Molasses! lettuce, then honey. That was a pretty quick race. Okay, so after careful review of the camera footage, we've determined how fast these fluids cross the finish line. So cane syrup came in at 6 seconds and 38 milliseconds. Pancake syrup came in at 2 seconds and 18 milliseconds. Honey came in at 8 seconds and 98 seconds. And molasses at 8 seconds and 28 milliseconds. So quite a difference you see when we have our temperatures warmed up by a few degrees. Okay, welcome to part 2 of our experiment. So we've put our races behind us, and now what we're going to do is we're going to be seeing how quickly an object is going to sink when placed in oil. So here we have our scoreboard. So we're testing olive oil and canola oil. We're going to be, our first part is going to be when the oil is very cold. So these have been in the freezer. They've actually been outside for a few hours, and then while we filmed the last part, this was sitting in the freezer, so it's super cold. We'll take the temperature of those shortly. We'll keep track of the temperature and how long it takes for the object to drop to the bottom. Okay, it's time to temper oils for part 1. Part 2, freezer oils. So this one here, it's kind of cloudy. This one's olive oil. And I mentioned earlier, this one just came out of the freezer, so it was almost as solid because we had cooled the temperature down. And as I mix this up, it's coming in at 12 degrees. So olive oil is at 12 degrees. There. Okay. What about canola oil? Let's test that out. This one also just came out of the freezer. All right. And canola oil settled in at 14 degrees. So not quite freezing temperature, what we might know, but this is how cool they are right now. It's slightly below room temperature. Room temperature is about 20 degrees Celsius. Let's see how this goes. So after carefully reviewing the footage, it has been determined that the dye took 12 seconds and 1 millisecond to drop to the bottom in the olive oil. And for the canola oil, it took 9 seconds and 48 milliseconds to drop to the bottom. So it was a little bit quicker in the canola oil. All right, so now we're on to another part of part 2. We're going to be seeing how quickly the dyes drop at room temperature. So let me just go ahead and temp the oil. And there we have it, almost perfectly at room temperature. Our olive oil is coming in at 21 degrees Celsius, and our canola oil is coming in at 22 degrees Celsius. So let's do our experiment again to see how quickly the dyes drop. So again, after crunching the numbers, we have our results The dye in the olive oil took 7 seconds and 62 milliseconds to drop, and the dye in the canola oil took 6 seconds and 58 milliseconds to drop. This is for room temperature. Okay, it's come down to it. It's the last trial of our experiment. So this is part 2. We're going to see how fast dice fall into oil at a warmed temperature. So put these in the microwave for about 40 seconds. They sat in the microwave for a little bit, that's why I hesitated. Let's see what they temp at. So there we have it. The olive oil is temping at 55 degrees Celsius and the canola oil is temping at 53 degrees Celsius. So our final trial, let's begin. So there we have it, trial 3's results. This is with the warm temperature. So this was in the microwave for about 40 seconds. And the olive oil, the dye in olive oil dropped after 3 seconds and 42 milliseconds. And the dye in the canola oil dropped after 3 minutes and 34 seconds. So Fred and I want to thank you for taking the time to watch this experiment. I hope you're able to put the results together and draw some conclusions about viscosity and fluids and how it's related to temperature. So that's kind of what we're going to go into next when we talk about fluids, is what kind of factors can affect viscosity. What do you think, buddy? Fred's not so sure. He just thinks about food and chasing other dogs. So good night, everyone. Hope you enjoyed the experiment.